Hello everyone, today our chapter is spectrum, and in this chapter we will see what happens to the ray of light when it passes through the prism. Okay, now to start with, let us draw a prism and let the ray of light be incident on a prism. Since we have done this topic already in our previous chapter, we will go through it really quick. Okay, now if there was no prism, then the light would have traveled in this direction. Alright, but now since there is a prism out there, light will not follow this pattern or this path, but it will actually refract and move in this direction. Again, now the ray of light has reached the second surface. Again, if there was no second surface, the light would have traveled straight in this path, but since there is a refraction in second surface, light will travel in this direction. Okay, now we see as if the light is coming from this point. Okay, from this diagram, let me show you. From this diagram we see as if the light is coming from this point in this direction. Okay, so this was the original direction, this is the final direction of the emitted light, so this angle is called angle of deviation. Okay, this is called angle of deviation, and by now we already know when a light passes through the prism, it deviates. Okay, there is a deviation, and later on when we move on, okay, when we move forward in this chapter, we will know that when the light enters the surface, it will split into different components, and different components have different deviation. Now let us try to understand what happens to the ray of light. Okay, what happens to the white light when it passes through the prism. Okay, again, this is also called Newton's experiment. Okay, here we will learn the dispersion of white light. Okay, right now I am using the term white light. Okay, white light does not necessarily mean it is white in color. Okay, so white light means any ordinary light without any color. Okay, actually it is colorless, but in physics we say it is a white light. Now first let us draw a prism. Okay, the triangular shaped object out here is a prism, and that rectangular shape which you see in the screen, okay, it is our screen where we see the different colors when the light passes through the prism. Okay, now there's a yellow line which you can see in the prism, ignore that for now. Okay, now let us start. Let this be our incident white light. Okay, this is our incident white light. Right now we can see there's a single ray. Okay, there's a single ray of white light incident on a prism, but after the ray strikes the prism, okay, first I also a ray of light gets deviated from first surface, again from second surface it gets deviated. Okay, here I am showing you red color, but actually it looks somewhat like this. Now what is this? Let me explain you. Okay, now when the light enters the first surface, okay, when the light touches the first surface, there will be dispersion of light. Okay, the dispersion of light means the phenomena of splitting of white light into its constituent colors. I'll show you the definition, we'll discuss this in another section, but for the time being you can understand from here that from this surface, from this point, the light is getting dispersed. Okay, it is splitting. Out here there is only white light, sorry, only one light, but out here you can see there are 7 lights. Okay, the 7 colored lights. So one light gets getting split into 7 different colors. Okay, this experiment is Newton's experiment, and you can learn it in your book. Okay, if you want to learn about this experiment, I'm telling you only the outcome. Okay, telling you only the outcome of this experiment. Now if you notice this, let me rub this first. If you notice the pattern, there is red at the top, orange, yellow, green, blue, indigo and violet. Okay, it is following this pattern if you look at this diagram properly. And all this color will form a band in this screen. These colors will form a band in this screen, okay, which is called spectrum, and we'll learn about that spectrum later. So right now, from this experiment, what we come to know is white light is composed of 7 different colors. Okay, white light is composed of 7 different colors. All right, now, so why different colors are deviating by different amount? The question might come, why the different light deviates by different amount when it passes through the prism? The answer is because of speed of light. Okay, different colors have different speeds. In air, all of them have same speed. That's why we see no different colors out there. Okay, all are moving together, because in air or in vacuum, light has same speed. But as soon as it enters the medium, the light will have different speed. Different colored light will have different speed, and the different components will deviate by different amount. So the main reason is speed of light. Because of different speed of light, because of the different speed of the different colors, light will deviate by different amount when it passes through the prism. And if you can see the pattern, red is at the top and violet is at the bottom of this pattern. It is because red deviates the least and violet deviates the most. Red deviates the least and violet deviates the most because red has the highest speed and violet has the lowest speed. Okay, red has the highest speed, so it deviates less. Violet has the lowest speed, okay, so it deviates the most. Now this is the reason. Okay, now if the question comes, what is the reason for the dispersion of white light? The answer should be because of the different speed of the different components of light. Okay, now let us move to the next topic. It looks like this. See, red will occupy the top position. After that, orange, yellow, green, blue, indigo is missing. Then there will be violet. Okay, it forms a pattern. Right. So this is a real picture. Okay, it will look somewhat like this. I assume that you have seen this kind of picture already. Okay, so this is how the ray of light looks when it passes through a prism. Alright, now let us move to the next topic. Dispersion. I have already discussed it. It is the phenomenon of splitting of white light into its 7 constituent colors by a prism. Okay, the prism splits white light into 7 different colors. Now what is spectrum? It is a band of colors obtained on a screen because of dispersion of light. Okay, we have discussed already. After the ray of light gets dispersed by a prism, the ray of light will form a definite pattern or a band on the screen. That band is called spectrum. Okay, now there are 2 types of spectrum. One is called artificial spectrum, one which we know. Okay, and another one is called natural spectrum, and rainbow is an example of natural spectrum. Okay, here we can see it is forming a spectrum out here. Okay, and see out here also they both look similar. Red at the top, after that orange, yellow, green, and at last there will be violet. Okay, but we cannot see the violet properly out here in this rainbow. Okay, and these colors are not distinct. Okay, this spectrum, the spectrum formed by the white light, is not distinctly separated. Okay, they are overlapping. No one can separate the colors in a spectrum of white light. Okay, they all are overlapping. All right. Now look at this note. Dispersion occurs only at the first surface of the prism, but deviation occurs at both surfaces. Now what does this mean? Now look at this first surface. Look at this surface. Out here there is deviation as well as dispersion. White light is getting splitted from first surface, isn't it? But when the light reaches second surface, it is not getting splitted further. Okay, only deviation is occurring in the second surface. So deviation occurs from both first and second surface, but splitting occurs only from the, or splitting or dispersion occurs only from the first surface. Okay, now our next important topic is electromagnetic spectrum. This is going to be very important topic for class 10. Okay, you can expect few questions from this section, objective questions. Okay, now what is electromagnetic spectrum? Electromagnetic spectrum is the spectrum obtained by arranging different electromagnetic waves in increasing or decreasing order of its frequency or wavelength. Okay, now before explaining you what is electromagnetic spectrum, let us discuss what is electromagnetic wave. Electromagnetic waves are those waves which has both electric and magnetic components. Okay, for example, white light. The light is an example of electromagnetic wave. Gamma ray, X-ray, all those are example of electromagnetic waves. Okay, they are called electromagnetic because they have both electric as well as magnetic components. And one common property, or one common behavior, one common characteristic of all electromagnetic wave is they have same speed, 3 into 10 to the power 8 meter per second. All electromagnetic waves travel with this speed in air or in vacuum. Okay, but in medium, as we know, they have different speeds. Alright, now let us go to the definition. It is a spectrum obtained by arranging different electromagnetic waves in increasing or decreasing order of its frequency or wavelength. Different electromagnetic waves have different frequency, they have different wavelength. Okay, different electromagnetic waves have different frequency, they have different wavelengths. Now if we arrange all these electromagnetic waves either in increasing frequency or in decreasing frequency, or in increasing wavelength or in decreasing wavelength, if we arrange these electromagnetic waves, they form a band or they form a pattern. Okay, this is called electromagnetic spectrum. Now let us understand what is electromagnetic spectrum in details. Okay, now I have made 7 compartments. Okay, now in these compartments, first I have written radio wave, second is microwave, third is infrared, fourth is visible radiation, and I have written this, I'll come to this later on. Then ultraviolet radiation, then X-ray, then gamma ray. Okay, now before moving further, give me a moment. Okay, alright, now see. Okay, radio wave, microwave, infrared radiation, visible radiation, ultraviolet, X-ray and gamma ray. Now in order to remember this, okay, I want you to learn this. Ram is very ugly but extra genius. No offense. Okay, I'm not trying to make fun of this name Ram. Okay, I'm not making fun of this name, but it becomes easy. Okay, in order to make you all understand, okay, I'm saying this, Ram is very ugly but extra genius, but I'm not intending to make fun of anyone. Okay, I'm not making fun of anyone, it is just to make you all understand. Okay, so if any one of you have relatives or your father or brother named Ram, don't take it by heart. Okay, it is just to make you understand. So Ram is very ugly but extra genius. Now why I'm telling you this is, R stands for radio waves. R of Ram stands for radio wave. M stands for microwave. RAM. Okay, M stands for microwaves. Is I stands for infrared. Ram is V, very. V stands for visible radiation. See, RAM. Ram is very, V for visible, ugly, U for ultraviolet radiation, is extra genius. Extra genius. RAM is very ugly but extra genius. If you remember this, why I'm telling you this is, if you remember this, you will learn a pattern. Okay, it will be easy for you to understand the pattern of the spectrum. Right now, RAM is very ugly but extra genius. Radio wave, microwave, infrared, visible, ultraviolet, X-ray and gamma ray. Now you can see, after radio wave there is microwave, after microwave there is infrared, just after infrared there is red. Okay, then orange, then yellow, green, blue, indigo, violet. Again, immediately next to violet there is ultraviolet. After infrared there is red, after violet there is ultraviolet. Okay, again I'm repeating the pattern. After infrared there is red, orange, green, yellow, blue, indigo, violet. After violet there is ultraviolet, then X-ray and gamma ray. Okay, so these red, orange, green, blue, indigo, violet are called visible radiations because we can see them, isn't it? We can see these colors, that's why they are called visible radiation. So the question says, or the explanation says, it is infrared. So why we can't see infrared radiation? Because it has such wavelength and frequency, not frequency, such wavelength that it does not fall into visible region. Okay, that's why we don't see infrared radiation. So the example of infrared radiation is, all of us have TV at home and we all have used the remote control of television, isn't it? When we press the buttons of the television remote, at the tip of the remote there is one small red light. Okay, when we press the button we can see red light, but when we try to see the path of the light we cannot see the red light passing. Okay, but we know there is a red light, so that ray of light is called, not their ray of light, but that red light is called infrared. Okay, we cannot see it but it is there. Alright, now after infrared, visible, after that ultraviolet, after that X-ray, after that gamma ray. Now why is this electromagnetic spectrum? Why this is spectrum? Because I have arranged these all radiations in increasing order of frequency or decreasing order of wavelength. Now what does this mean? It means it has low frequency, little higher frequency, little higher frequency, little higher and highest. Okay, the frequency is increasing, and again, in another words, highest wavelength, and the wavelength keeps on decreasing. Alright, now what type of question comes from here? I'm just giving sample questions. Okay, consider you have infrared, ultraviolet and gamma radiation. Infrared, ultraviolet and gamma radiation. Arrange these rays in increasing frequency. What will you do? Infrared, ultraviolet and gamma. You will write answer like this, of course in full words. Okay, so answer in increasing frequency, infrared, ultraviolet and gamma. If you get the question, arrange infrared, ultraviolet and gamma radiation in decreasing wavelength, what will you write on? Decreasing wavelength. So which one is the highest wavelength? Infrared, then ultraviolet, then gamma. It is decreasing wavelength. Okay, so it becomes easy for you, okay, if you know which radiation lies in which place. And I already told you RAM is very ugly but extra genius will help you a lot. Okay, if you can remember that, it will help you in solving the questions in this chapter. Okay, so in this spectrum the frequency is increasing from radio wave to gamma ray. So the highest frequency gamma ray, lowest frequency radio wave, highest wavelength radio wave, lowest wavelength gamma ray. And what about these visible radiations? See, just after infrared there is red. Okay, this will help us to understand the pattern actually. How? Red has the highest wavelength, we know that. Violet has the lowest wavelength. So this side wavelength is higher, this side the wavelength is smaller. Okay, and it is decreasing in this direction. red has the highest, violet has the lowest, so the wavelength is decreasing in this direction. Okay, if you know this, you can understand the pattern from here also. So this is very, very important, okay, part. So I want you all to remember this, okay. And the question which comes in Icse is like source and uses, okay. I want you all to learn the sources and uses of all these radiations, okay. It is in page number 140 of concise physics, okay. It is in page number 140 of concise physics. There's a table. I want you all to remember the sources and uses of these radiations, okay. For example, gamma ray. Where do we find gamma ray? Source. It is a cosmic radiation, isn't it? It is a cosmic ray, so it is formed in cosmos. It means in our universe it is there, okay, cosmos. And what is its use? It is used in what I call treating cancer, gamma radiation, okay. That is one use. And X-ray, source of X-ray, it is obtained when a heavy metal is struck by a highly energized, okay, electrons. When highly energized electrons strikes a heavy metal, okay, inclined at certain angle, then certain radiation will emit out. That is called X-ray, okay. So we know the source of X-ray now. And what is its use? It is used to detect the fracture of our bones, okay, flaws in metals, like that. I want you to learn the sources and uses of all the radiations from your book. If you are using concise physics, it is in page number 140, okay. So this is all from this chapter.